Hi, welcome to the video. Today we'll be going through tangent lines and normal lines of a curve and how to solve them using differentiation. So you had a curve like that. Now each curve has a slope but at different points. So you had a point here, a point there, and a point there. There'll be a slope there at that specific point, another slope there, like that, at that specific point, and another slope there at that specific point. And as you can see, each slope is different. So at each point, there'll be a different slope, and you can use differentiation to get the value of that slope. And these slopes are also known as tangent lines of a point. So just to redraw this again, if I had a curve like that, and at that point there was a slope like that going through it, it's also known as a tangent line. And the line perpendicular to it there at the right angle is a normal line. So if you got the differential dy dx of this curve, you can figure out the slope at a specific point. So dy dx at a specific point, say x0, y0, is equal to the slope, change in y over change in x at that point. Now, and to get to the equation of this tangent line, you can use this formula: y equals y0 prime x0 y0 x minus x0 to get the equation of the line. This f prime x0 y0 is this value here, which is the slope of the line, and using these change in points you can obtain the equation of the line. To get the normal line, this part here changes, and instead of f prime x0 y0, we use negative 1 over f prime x0 y0, and the rest of the equation stays the same. So let's do an example explaining how this would work. Say we had an equation x squared minus xy plus y squared equals 3. From here, we first want to figure out what derivative of this equation is, and we're going to derive it explicitly. So ddx of one side equals x squared minus xy plus square, and ddx on the other side is what we need to get. Let's start with this side. ddx of 3 is equal to 0. ddx of x squared is equal to 2x. ddx of x minus y squared. If we apply the product rule, we have x dy dx. Let's put this in brackets. X dy dx plus y, yeah, just y. And here, if we apply chain rule, we have 2y multiplied by dy dx. And then from this point, we can take this 2x to one side, so minus 2x that side. You can multiply them negative throughout. We have negative x dy dx minus y, and keep this the same, 2y dy dx. We can now take this y to that side of the formula so that we have dy dx on its own on this side of the formula. So y comes here, and we have 2x, leaving us with this 2y dy dx and this minus x dy dx. I'm just going to write this side. From this point now, I can factor out dy dx, and we have 2y minus x left over, which equals to y minus 2x. So our dy dx at the end of the day equals y minus 2x over 2y minus x. So this is the equation of the derivative of the curve, and we can use this equation to find the slope at an instant. So let me rewrite that here. We have dy dx equal to y minus 2x over 2y minus x, and we're told to find the slope, let's say at the point minus 1, 1. So our x0 is minus 1 and our y0 is 1. So that means f prime minus 1, 1 is equal to 1. I'm just substituting these values into this equation. So y is 1 and x is minus 1. So 1 minus 2 minus 1 over 2 1 minus 1, which is 1 plus 2 and 2 plus 1 gives us 3 over 3, which is equal to 1. So now if we want to find the equation of the tangent, we know we should use the equation y minus y0 equals f prime x0 y0 x minus x0, and we have our f prime x0 y0, which is 1, and we know our y0 is 1 and x0 is minus 1, so we can substitute that in. Then from there, work that out. That's the equation of the tangent line. If we're told to find the equation of the normal line, we need to know that the gradient of this equation is now equal to minus 1 over f prime x0 y0. That's the only difference. This was x, that's x0. So again, substituting in, we have y minus 1 equals minus 1 over f prime x0 y0 is equal to 1, luckily, and then x minus x0, which is minus 1. So y is equal to minus x, and that's our answer for the equation of the normal line. I hope this all made sense. Yeah, I hope it helped. Bye.